Hi, this is a lecture on constructions. In this lecture, we will look at how to bisect a given angle, how to draw the perpendicular bisector of a given line segment, how to construct an angle of 60 degrees, 90 degrees, 30 degrees, etc. To construct a triangle with its base, a base angle, and the sum of other two sides given, and to construct a triangle given its base, a base angle, and the difference of the two sides, and also look at how to construct a triangle when we are given its perimeter and the two base angles. Let's start with how to bisect an angle. This is pretty elementary. Say you have been given an angle, say theta. Theta is given, and we are supposed to bisect this angle. First, start off drawing this angle with two rays, and then taking this point as the center, an arbitrary radius on your compass, draw an arc, and with the same radius but this point as the center, draw an arc and join the vertex and this point, that is the intersection point of the two arcs, and this will be the angle bisector. These two angles will be equal. Let's see how this construction can be justified. To do that, name this point point A, this point is point B, this point is point O, and join A, and let's call the intersection point as point C, and join AC and join BC, right? So because this is an arc of a circle, we have OA is equal to OB, that is, which will be equal to the radius. So that is OA is equal to OB, radius of the arc that we had drawn initially to represent the angle itself. Then BC is equal to AC. BC is equal to AC because we had taken the same radius while drawing these two arcs, that is by construction, right? And we have OC common. OC is equal to OC, which is trivial. This implies triangle OAC is congruent to triangle OBC. This implies by corresponding parts of congruent triangles, angle AOC is equal to angle BOC. Hence, we have proved that our construction of angle bisector is justified. And so this is how you do it. Next, we will look at how to draw the perpendicular bisector of a given line segment. Say this is the given line segment AB, right? And let's see how we draw the perpendicular bisector of AB. Start off by choosing any radius on your compass, but it should be visibly larger than what could be the midpoint, or that is half the length of this line segment. So choose a radius, any radius, but larger than, considerably larger at least, than the then half of this line segment, then half of the length of this line segment. Say if AB is equal to 3 centimeters, your radius should be at least greater than 1.5. Right? So choosing a radius greater than then half the length of the line segment, from A as the center, draw an arc, and then draw an arc underneath the line also. And now taking the same radius but B as the center, draw an arc and repeat beneath the line, and then join these two points. Obviously this hasn't come out perfect because I really don't have a compass, but on drawing you'll notice this is 90 degrees and this side is equal to this side, right? And let's see how we can justify this construction. Join point A and point C, that is using this line, and join point A and point D, and point D and point B, and point C and point D. Really, you just need these two actually, but anyways, I do this just in case. So how do you prove that let's call this point O. AO is equal to OB. So we have to prove OA is equal to OB, as well as angle AOC is equal to 90 degrees, which is enough because that will prove that angle BOC is equal to 90 degrees also. And sorry, let's see how we do this. We have this side, that is AC, is equal to BC by construction, because we had used the same radius. So AC is equal to BC by construction. And now consider AB and BD. They are also equal by construction. AD is equal to BD. In fact, they are equal to AC and BC also, but we won't need to use this fact, so we'll just indicate by different signs. So anyways, AB is equal to BD and DC is equal to DC. We're just saying this is a common line. And so therefore, by SSS, we have triangle DCA is congruent to triangle DCB. This implies angle ACD or ACO, we choose to call it, is equal to angle BCO, right? So this angle is equal to this angle. Now AB is equal to BC, OD is equal to OD, and angle ACO is equal to angle BCO. This implies by SAS, triangle ACO is congruent to triangle BCO. This implies AO is equal to BO, and also we would know that angle AOC is equal to angle BOC, and AOC and BOC are angle AOC and angle BOC are linear pair of angles. This implies angle AOC is equal to angle BOC is equal to half of 180 degrees, which is equal to 90 degrees. Hence proved. Right? So we have justified this construction also. Now we'll see how to construct angles of say 60 degrees or some other general angle. We'll start off with 60 degrees. So start with the base ray, and now with this point as the center, draw an arc of arbitrary radius, preferably small. Now with the same radius but this point as the center, cut the initial arc. And now this point, with this point as the center, join these 2 points and extend this ray. This angle right here is equal to 60 degrees. How do you prove that? It's pretty simple actually. Name this point O, name this point A, and this point is B. And OA is equal to OB, OA is equal to OB by construction. And also AB is equal to OA. AB is equal to, and therefore is equal to OB. AB is equal to OA is equal to OB, all by construction. This implies triangle ABO is an equilateral triangle. This implies angle AOB is equal to 60 degrees, because every angle in a equilateral triangle is equal to 60 degrees, right? And so hence this is the justification for how we constructed 60 degrees. Now let's look at how to draw 30 degrees. Say this was 60 degrees. Let's look at 30 degrees. 30 degrees is actually pretty easy. You just need to bisect 60 degree, of course. So using this method, that is how to bisect an angle, we can draw 30 degrees. So 30 degrees is covered. It's simply bisecting 60 degrees. Now 90 degrees, we can do a couple of things. I'll tell you both the ways. One way would be to extend the base and draw an arc. And now with this angle, we know that this angle would be 180 degrees, because this is the angle of a straight line. Bisect this angle, and so therefore we'll get half of 180 degrees, which is 90 degrees. So 90 degrees can be done in a lot of ways. One of them is to draw a straight line and then the angle over it, basically the arc over it, and simply bisect the angle 180 degrees, and so you'll get 90 degrees, which is basically just a straight line, right? And another way, slightly more complicated, something I wouldn't recommend, but obviously you can try, is to now take this base and draw 60 degrees here and then bisect that, and you'll get 30 degree here. Basically, if you drew 60 degrees and then bisected this, you'll get 30 degrees here, and with this 60 and this 30, you'll get 90 degrees. But I personally don't recommend this method, because that is much harder, and there's no need for you to do all of that when you get simply by bisecting 180 degrees. To get 45 degrees, bisect 90 degrees. Again, draw the straight line, the arc, and bisect this arc, which is actually a semicircle, and you'll get your 90 degrees, and bisect 90 degrees and you'll get 45 degrees. So bisecting 180 will give you 90, and bisecting 90 you'll get 45 degrees. There's various other things you could do. Say if you want 75 degrees, you'd have to draw 90 degrees, then 60 degrees, and then bisect this angle right here, which is 30 degrees. So this will be 60 degrees, this whole thing would be 90 degrees, and then bisect this angle here to get 15 degrees. So say if the bisected angle looked like this would be 60 plus 15, which will be 75, and hence you can draw 75 degrees. So drawing angles is pretty easy. Most of the general angles can be drawn pretty easily if you know how to draw at least 60 degrees, right? And now let's look at how to construct a triangle given its base, a base angle, and the sum of the other two sides. So let's just call this triangle ABC, and say the base were equal to BC, and so let's just draw the base, that is BC, and then say we are given the base angle, and let's just call it angle B, and let's just call it is equal to theta, whatever that be. This is theta, and we are given the sum of the other two sides. So AB plus AC is equal to, let's just call it A, and it's given, right? So let's see how we can do this. First, start off by drawing the base, then draw a ray at the given angle. We've drawn the base, this is given. We've drawn the base, then draw a ray at this angle. We've drawn that, and then using your compass, cut this ray at A, that is using the radius as A and your compass with the center B, cut the arc so that, and let's just call this point X, so that this length, this whole length is equal to A, which is equal to AB plus AC. Right. Now join C and X. Join C and X. Right. And now measure out this angle and call this, say, phi. So we have AXC angle AXC is equal to phi. Now using CX as base and C as the center, draw out a line segment to intersect DX at D such that DCX is equal to phi. So drawing a line segment, basically taking an angle phi on the base CX, draw out a line segment to intersect this point at D. So this angle is equal to this angle, and so therefore this is an isosceles triangle where this side is equal to this side, which is a property which says the angles opposite equal, the sides opposite equal angles are equal. So therefore DC is equal to DX. So we have AB is plus AC is equal to A is equal to DX, which is equal to BD plus DC. Sorry, BD plus DX. BD plus DX. We know that DX is equal to DC. So A is equal to BD plus DC, and so therefore we can conclude that D is in fact A and the required third vertex. So we can also call this point A, and so therefore triangle ABC is the required triangle. Right. So that's how you do the fourth construction, that is constructing a triangle with its given base, the base angle also given, and the sum of the other two sides. Now there are two more constructions that we need to discuss. We'll cover that in the next lecture. For now, this is all. Thank you.